Good morning to everyone. Today we will discuss about relational operators, logical operators, assignment operators, increment, decrement, statements or operators, bitwise, OR and XOR operators. Okay, today we will going to discuss all about the operators that we use in C. So first we discuss about the relational operators. So relational operators are used to compare two or more operands. Okay, like arithmetic operators, relational operators are also used to compare two or more operands. And these operands may be variables, constants, or expressions. Operands can be variables, those can be constants, or those can be expressions also. Okay, so for example, we may compare the age of two persons or the price of two items. Okay, like this. Okay, we can compare the age of the person, we can compare the prices of two items, and this comparison can be done with the help of relational operators. So by using the relational operator only, we can do this comparison operation. An expression containing four relational operators is termed as a relational expression. Okay, so if it is having the relational operators, if the expression is having relational operator, then we call it as the relational expression. The value of relational expression is either 1 or 0. The expression or the result or the value of the relational expression is either 1 or 0. It is one of the specified relation is true and 0 if the relation is false. So if it is 1 means it is true and 0 it means it is false. And C supports 6 relational operators. Okay, the following are the various relational operators that C supports. The first one is less than operator. Less than operator. So in this example, see, 9 is less than 10. So yes, 9 is less than 10 means it is true. True means 1. True means 1. And here it is greater than operator. This is a greater than operator. So here 9 is greater than 10. So this statement is false. False means it is 0. It is 0. And here it is less than or equal. Less than or equal. Okay, so here 9 is less than or equal to 9. Yes, 9 is equal to 9. One condition is true. It is not less than, but 9 is equal to 9. One condition is true here. So the result is true. True means 1. And it is greater than or equal. Greater than or equal. So here it is 10 is greater than or equal to 9. Yes, 10 is greater than 9. So this is true. Okay, this expression is true. True means it is 1. It returns 1. And here it is equal to. This is a equal to operator. So here 5 is equal to 9. So this is false. 5 is equal to 9 is false. False means it is 0. So this is not equal to. Not equal to. Okay, see, observe this example. 5 is not equal to 9. Yes, this expression is true. True means it is 1. Okay, so this is about various relational operators. Less than, greater than, less than or equal to, greater than or equal to, not equal to. All these are the various relational operators. So here all relational operators needs two operands. So to perform the relational operators, we need two operands. And relational operators are used in decision making process. So by using the relational operators, okay, we can conclude the decision or we can conclude the result, and they are generally used in conditional and control statements. These operators are generally used in conditional and control statement. Conditional statements and control statements, we use the relational operators. Next we discuss about the logical operators. Logical operators. Okay, so the logical operators are used to combine the result of two or more conditions. Okay, this is used to combine the result of two or more conditions. And C language has the following three logical operators. There are three logical operators in C. The first one is the not. This is the not operator. And this is the logical AND operator. And this is the logical OR operator. Not, logical, not, and logical OR. So these are called logical operators. So here the not operator is a unary operator. So here it is a not is a unary operator. Okay, meaning of unary nothing but we can use this operator on single operand. We can use this operator on single operand. And while the other two operators are binary operators. So remaining these two are binary operators. Here we use two operands to perform the operation. Okay. The logical operators and are used when we want to test more than one condition and make decision. So whenever there is a case that whenever we want to test the condition, when we want to test more than one condition, in that case only we use logical and logical OR operators. So this is logical and this is the logical OR. So let us see here logical, this is the logical and, this is logical OR, and this is the not. Let us see the table, truth table. See, in the logical AND case, if the first operand is false and second operand is also false, then the result is also false. Okay. If the first operand is false and second operand is true, then the result is false. And if the first operand is true and second operand is false, then the result is false. Only in the case of true. So if the first operand is true and second operand is true, in this case only the result is true. For the remaining cases the result is false. Logical AND, if two operands are true, then the result is true. For remaining cases the result is false. So this is logical AND. And as we see about the logical OR table here, see, if the first operand is false and second operand is also false, then the logical OR result is also false. If the first operand is false and second operand is true, then the result is true. Logical OR result is true. And if the first operand is true and second operand is false, then the result is true. Logical OR result is true. And if the first operand is true and second operand is true, then the result is true. So in this logical OR operation, if any one of the operand is true, if any one of the operand is true, then the result is true. Okay, for the remaining case it is false. So this is our logical OR. And next is the NOT operator here, logical NOT operator. So not nothing but it is the inverse of the input. So if the operand is false, the logical NOT operand will give true. If the operand is true, then the logical NOT operation will give false. It is inverse. If it is false, it gives true. If it is true, it gives false. This is the logical NOT operation. So let us see some examples here. Let us consider two variables I and j which are integers. I is assigned with 3 and j is assigned with 7. And also we consider or we declare two double variables here. F is declared with 5.5 and g is declared or assigned with 4.5. We are assigning the values 5.5 to f and 4.5 to g. And here it is a character variable, it is t. T is the character variable. So let us check the conditions here or with the expressions. So here I is less than or equal to 5. Is 3 is less than or equal to 5? Yes, means it is true. True. And see the ch character is equal to t. True. 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 In logical AND case, so if you observe here logical AND case, if both operands are true, true, then the result is also true. So this is true and this is true. And the logical AND operation result is also true. And the meaning of true is 1. The value here it is 1. True means 1. And here if you observe here, j is less than 8. Yes, 7 is less than 8. So this is true. Or ch is equal to L. But here the ch value is t. Okay, this is false. True or false? True, logical or false? So if you observe here, true, logical or false, the result is true. The result is true. Here also the result is true. And the value for true value is true means 1. And here it is f plus g is equal to 10. Okay, so f plus g, yes, 5.5 plus 4.5 it is equal to 10. The value of this is true. True, logical or, so here 3 is less than 2. 3 is less than true. This is false. This is false. True, logical or false. So you observe here true, logical or false. Here the result is true. Similarly here the result is true. True means 1. True means 1. And observe the next example here. F is greater than or equal to 6. F is greater than or equal to 6. But here 5.5 is greater than or equal to 6. So this is false. This is false. Okay, false, logical or. So here it is I into j. I into j means it is 21. 21 is less than 15. So this is false. This is false. Okay, true, logical or false. True, logical or false. The result is true. So here also the result. So in this case, okay, in this, okay, you have to check this. Okay, so f it is 5.5. 5.5 is greater than or equal to 6. This is false. False, logical or 21 is less than 15. So this is also false. This is also false. False, logical or false. The result is false. The result is false. False, false. The result is false. False means it is 0. Okay, so here it is not operation. Not operation. So if you evaluate this, f is greater than 5.0. Yes, 5.5 is greater than 0. So this case is true. This case is true. See, whenever we are performing the logical NOT operation on true, okay, logical NOT operation on true, it gives false. So here also it gives false. False means it is 0. False means 0. True means 1. Okay, so this is the various logical operations. And, or, and this is the not. Okay, that is about logical operators. And next we discuss about assignment statements. Assignment statements. As I discussed earlier, assignment operator nothing but is equal symbol. Equal symbol is considered as assignment operator. Okay, this assigns a value or an expression or a value of expression on the right side of it to the variable on the left side of it. So it assigns the value to the left side of the variable, or sometimes right side of the variable. It assigns the value. The assignment operator assigns the value which is left side of the expression. Okay. A statement is an instruction to the computer to perform a specific operation. A statement, nothing but it is a instruction. Okay. Instruction given to the computer to perform a specific operation. An assignment statement is an assignment expression followed by a semicolon. See, in assignment expression we use the semicolon at the end of the statement. And here, if a semicolon is placed at the end of an assignment expression, the result is an assignment statement. Okay, for example, if you see here, say x is equal to 15. See, it is an assignment expression. Assignment expression. So, whereas x is equal to 15 semicolon is an assignment statement. So, this is the assignment statement. So, here it is ending with semicolon. Okay. So this is called assignment statement. This is called assignment expression. This is expression and this is statement. Assignment statement. See, this is general form of assignment statement. So here variable is equal to value or expression. This should end with semicolon. The assignment statement should end with semicolon here. Okay. So here these are the assignment expressions and these are the assignment statements. Okay. Keep in mind that assignment statement should end with semicolon, whereas the expression will not end with semicolon. Only the assignment statement ends with semicolon. So here x is equal to 10. So this is assignment expression. Whereas x is equal to 10 semicolon, this is the assignment statement. And here it is x is equal to a plus b. This is assignment expression. So whereas x is equal to a plus b semicolon, this is the assignment statement. And here it is x is equal to y into y. So this is assignment expression, whereas x is equal to y into y ends with semicolon. This is a statement. Assignment statement always ends with semicolon, and expression will not end with semicolon. Expression will not end with semicolon, whereas the assignment statement ends with semicolon. Okay, so next types of assignment statements. Let me discuss about types of assignment statements. And C language supports different types of assignment statements. So there are 4 types are there: general assignment statements, declaration assignment statements, multiple assignment statements, and increment or decrement statements. All these are the various assignment statements that is supported by C programming. Okay, first we will discuss about general assignment statement. Okay, so here according to this statement, an expression or a value can be assigned to a variable using the following syntax. See, this is the syntax for general assignment statement. So variable is equal to expression or value, ends with semicolon. Variable is equal to expression or a value and ends with semicolon. So for example, consider here, see, a is equal to 10 plus 20 into 30 ends with semicolon. So this is equal to a is equal to 70. So these are the examples for general assignment statements. These are the examples for general assignment statements. And next is the declaration assignment statements. Declaration assignment statement. So the initialization of variable is possible at the time of declaration itself. So whenever you are declaring the variable, then only you can also initialize the value. Okay, so this is called declaring the variable to the declaring a value to the variable. This is called declaring a value to the variable. So in this case, the declaration must consist of a data type followed by a variable name, an equal sign, and a number appropriate to the data type, and finally a semicolon. See this is the syntax: data type followed by variable name and equal symbol, and with expression or a value that should end with semicolon. Okay, so this is the syntax for assigning or assigning a value to the variable. See, these are the examples here. See, int is the data type, x is the variable name, and equal is the equal symbol, and 1 is the value that is assigned to x, and it is ends with semicolon. It is ends with semicolon. See, 1 is a integer value. 1 is a integer value. That value is assigned to x, and x is a integer data type. The next example, float, sum is equal 0.0. So here sum is a float data type. Sum is a variable which is a float data type. That is the reason why we are assigning a float value here. We are not assigning 0. Here we are not assigning 0. We are assigning 0.0. The reason is sum is a float data type. That is the reason why we are assigning 0.0. 0.0 is different and 0 is different. Okay, and here it is char ch is equal, within the single quotation we are giving the value y and ends with semicolon. So y is a character and ch is a variable name, and it is a character data type. It is a character data type. So this is about declaration assignment statements. And next is the multiple assignment statements. Multiple assignment statement. So according to this statement, more than one variable can be assigned to a single value or an expression using the following syntax. See, in this case, multiple assignment statement, we can assign more than one variable with a value, with a single value. Okay, so here is the syntax. Variable 1 is equal to variable 2 is equal to variable 3, that is equal expression or a value that ends with semicolon. So this is the example. So in this example, a is equal to b is equal to c is equal to 10. The 10 is assigned to c in the same way the 10 is assigned to b, in the same way the 10 is assigned to a. Now a is 10, b is 10, and c is 10. So this type of assignment or this type of statements are called as multiple assignment statements. Multiple assignment statements. And next we discuss about increment decrement statement. Okay, so here increment decrement statement. So with assignment we can use either increment decrement operator. So here with assignment or with assignment we can use the value or the expression like this. This is called increment operator. Increment operator. So for example, if you consider a is equal to plus b, consider this example, a is equal plus b. Here plus b is a increment operator. It is a increment operator. See what this do is, if you consider b value as 5, b value as 5. See, this is the prefix increment. Prefix increment. So what this will do? First this will increase the b value and then the value is assigned to a. First this increases the b value and then the increased value is assigned to a. If you consider b is equal to 5, then the b becomes 6. First this increase the values. First this increments the value of b. If b is 5, then plus b becomes 6. B becomes 6 and that result is assigned to a. Now a becomes 6 and b becomes 6. So this type of operation is called as increment operator. Increment operator, and that value is assigned to a variable a. Okay, so this is a prefix increment. Prefix increment. Say for example, if you consider this example here, a is equal to b plus plus. So this is the postfix increment. This is called postfix increment. The postfix increment value is assigned to a. So how this will work? Let us see how this will work. So if you consider b is equal to 5, first it assigns the 5 to a, okay, and then it increases the b value. And then it increases the b value. See here a is equal to b plus plus means first it assigns the b value to a Now the b value is 5, so it is assigned to a. After that, b is incremented by 1. B is incremented by 1. B plus plus means we are increasing the b value by 1. Now b becomes 6. So this is called postfix increment. Postfix increment. In postfix increment case, first it assigns the value and then it increases the value. See, 5 is assigned to a and now the b is incremented by 1. B plus plus means b is incremented by 1. That is 5 becomes 6 here. Okay, so this is called increment operation. Okay, let us discuss about this increment and decrement operators. Okay, in certain cases the value of a variable to be incremented or decremented by 1. Okay, in some cases the programmer want to increase the value or value of the variable by 1, or in some cases the programmer want to decrement the value of the variable by increment or by decrement. Okay, in such cases we use increment decrement operators. And C uses two very useful operators not generally found in other languages, and these are called as increment operator. Plus plus is the increment operator and minus minus is the decrement operator. And the plus plus adds 1 to the variable, so it increases the value by 1, and minus minus this will subtract or it will decrement the value by 1. Okay, and these are the various types. So plus plus a means it is a prefix increment. Prefix increment. Minus minus a means it is prefix decrement. A plus plus means it is postfix increment, and a minus minus means it is postfix decrement. Okay, all these are the various prefix and postfix increment decrement operators. Okay, so here plus plus a is equal to a plus 1. This is same as plus plus a is same as a is equal to a plus 1. The meaning of this is we are incrementing a by 1, or this can also written as a plus is equal to 1. Okay, so this is a shorthand assignment. We call it as a shorthanded assignment operator. A plus equal to 1. This is same as a is equal to a plus 1. This is same as a is equal to a plus 1. And here minus minus a is equal to a minus 1. This is same as a minus 1. We are decrementing the value, or this is a decrement operator. Minus minus is a decrement operator. It decreases the a value by 1, and this is same as a minus is equal to 1. So minus equal to, this is the shorthanded assignment operator. Minus is equal to, it is called as shorthanded assignment operator. So what this will do, this will decreases the a value by 1. This is same as this one. Okay, and let me discuss about the increment operator. So this operator is used to increment or is used to increase the variable of an integer quantity by 1. It increments the variable value by 1, and this is represented by plus plus. To represent the increment operator, we use the symbol plus plus. This is the double plus. We call it as a double plus symbol, and this symbol can be placed either before or after an integer variable. See, this plus plus or double plus plus can be placed before or after the integer variable, and these are further subdivided into two categories. The increment operators are again subdivided into two categories. One is prefix increment and this is the postfix increment. Okay, let us see the prefix increment and postfix increment. Okay, so here it is increment and assigns. First, prefix, in the prefix increment case, first it increases the value and then it assigns the value to the variable. And in the case of postfix increment, it first uses it and then it increases it. First it assigns and then it increases. Okay. And next, in the prefix increment operator, first of all value will be incremented. Yes, the value is incremented and then the incremented value will be assigned to the variable. First we will do the increment operation and then the value is assigned to the variable. In this case, In this case, first we assign the value, and then we increment the variable value by 1. Okay, so this is the example here. A is equal to plus b. The meaning of this A is equal to plus b nothing but first this will increase the b value by 1 and then the b value is assigned to A. Okay, so this is equal to two statements, that is b is equal to b plus 1. First this will increases the b value by 1 and that b value is assigned to A. This is called prefix increment. So here it is a postfix increment case. First we assign the value. First b is assigned to A and then b is incremented by 1 and then b is incremented by 1, that is b is equal to b plus 1. So this is same as these two statements. This is called prefix increment and this is called postfix increment. And next we discuss about the decrement operator. So here this operator is used to reduce the value of an integer quantity by 1. Increment operator, it increases the quantity by 1. Decrement operator, this will decreases the variable quantity by 1. And this is represented by minus minus. This is called double minus. Minus minus means it is a double minus symbol. And this symbol can be placed either before or after the integer variable. Similar to increment operator, minus minus double minus is also placed before or after the integer variable. And again the decrement operators are classified into or divided into two types: prefix decrement and postfix decrement. See here in this example. Okay, so the first one is the prefix decrement and here it is the postfix decrement. So these are similar to prefix increment and postfix increment. There we increase the value, here we decrease the value. Okay, that is only the difference. So in this prefix decrement operator, first of all we decrease the value by 1 and then we assign that value to the variable which is at the left side. Okay, so in this case, first we assign the value and then we decreases the variable value by 1. Okay, see, let us see this example here. A is equal to minus minus b. See, in this case what we do is first we decreases the b value by 1, b minus 1, and then the value of b is assigned to A. The value of b, whatever the result we are getting here, that value is assigned to A. So this single statement, prefix decrement statement, is equal to these two statements: b is equal to b minus 1 and A is equal to b. Okay, so this is a prefix decrement. So in the case of postfix decrement, first we assign this value, b value is assigned to A and then b is decreased by 1. First we assign the value b value to A and then we decreases the b value by 1. This single prefix decrement statement is equal to these two statements. First we assign b value to A and then we decrease the b value by 1. Okay, so this is called postfix decrement. And next we discuss about bitwise operators. So here bitwise AND, bitwise OR, bitwise XOR are the binary operators. The meaning of binary operator is nothing but we use these operators on binary values. And the result is produced. And it produces the result depending on the comparison of corresponding bits. As we said before, these are used to perform operations on bits. Okay, for example, if you consider A is equal to 4, that is equal to, if you write the 4 in bits format, 8-bit format, then the 4 is equal to 0, 0, 0, 0, 0, 1, 0, 0. The 4 is equal to this value in binary format. And if you consider B is equal to 3, then the binary equivalent for the 3 is 0, 0, 0, 0 and 0, 0, 1, 1. This is binary equivalent for 3. If you perform Logical AND on A and B operators. Okay, A and B operators. AND means if both are true, then only the result is true. If these both are true, if this is true, then only the result is 1. For remaining cases, it is 0. See, observe here, this is 0, this is 1. Okay, result is false, it means 0. This is 0, this is 1, and the result is false. It means it is 0. And here it is true, true, false. The result is false. Okay, the result is 0. This is false, 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 bitwise and false. The result is also false here. And here it is false. Okay, bitwise and false. The result is false. False means 0. For remaining cases also it is 0, 0, 0. See the bitwise and between A and B is 0, 0, 0, 0, 0, 0, 0, 0. So this is called logical, we call it as the bitwise ANDing. This operation is called bitwise ANDing. Okay, so next we see the bitwise OR. Bitwise OR. Okay, so in the case of bitwise OR, the result of bitwise ORing is 1 if one of the bits is 1. If any one of the bit is 1, then the result is 1. If any one of the bit is 1 in these two, if any one of the bit is 1, then the result is 1. Okay, otherwise it is 0. See, in this case it is 0, in this case this is 0, in this case this is 0, this is 0, this is 0. Okay, say for example consider the same value here, A is equal to 4 and B is equal to 3. Now we are performing bitwise OR operator, A or B. This is a OR operator, A or B. So here it is 0, 1. Okay, so it is false, it is true. The result is true. In OR operator, if any one of the bit is 1, the result is 1. For remaining cases, it is 0. So 0, 1, it is 1. 0, 1, it is 1. 1, 0, it is 1. See, any one is 0. Any one of the bit is 0, 1, then the result is 1. And for the remaining cases, all are 0. Here all are 0, here all are 0. So the result is also 0. Okay, so this is the bitwise OR. The bitwise OR operation on A and B results 0, 0, 0, 0, 0, 1, 1, 1. Okay, so this is bitwise OR operator. And next is the bitwise XOR. So in the case of XOR, the result bitwise XORing is 1. Okay, if the bits are different. If the bits are different, then the result is 1. If the bits are different, the result is 1. Okay, if the bits are same, the result is 0. Otherwise, it is 0. When both are zeros and both are ones, then it is 0. Okay, so in this case here, if you observe here, it is 0, it is 1. Okay, if bits are different, here bits are different, so the result is 1. Here the bits are different, so the result is 1. Here the bits are different, so the result is 1. Here the bits are same, both are same, so because of that the result is 0. Here also same, the result is 0. Here also same, the result is 0. Here these are two are same, the result is 0. These two are same, the result is 0. If both bits are same, the result is 0. If both bits are different, then the result is 1. The result is 1. Okay, both are same, then the result is 0. If in the case it is 1, 1, then also it is 0. Both are same, both bits are same, so the result is same, and in that case also. If it is 1, 1, then also it is 0. That is called XOR, bitwise XOR operator. Okay, so this is for today class. Thank you to everyone.